AP Biology, this is our third and final video on Chapter 26. We're specifically looking at hormones or chemical regulation or maintaining homeostasis within the body using chemicals. This is our third and final video. It is in reference to all of the endocrine glands besides pituitary. So one of the major hormones that helps maintain homeostasis is the endocrine gland, the thyroid. And what the thyroid does is it determines or regulates your development and your metabolism. And one of the big things about the thyroid is that it actually affects all of our tissues. It affects everything else. And some of the major things that are being produced by the thyroid are the hormones called thyroxin, and they get abbreviated thyroxin 4 or T4, T3. They play a critical role in how we develop or mature. And what the thyroid hormones do is they control our blood pressure, our heart rate, our muscle tone, and our digestive and reproductive functions. So if you're not sure if there's a hormone and what it does, just automatically assume that hormone is probably the thyroid and that it's controlling almost everything in our body. One of the things that can happen is if your thyroid is overactive and it's creating too much thyroxin, it's called hyperthyroidism. And one of the things that it results in is Graves' disease. And Graves' disease looks something like this, where there's that excess production around the eyes, kind of sunken, discoloration. Now, one of the other things that can happen is you can actually have a thyroid that doesn't produce enough thyroxin. And what can happen is that you can actually have that happen because there's a defect in the genes, or sometimes your diet doesn't have enough iodine in it, which is why our salt is often iodized or has iodine in it. And then you can get things like a goiter, which is like big, large swelling on the neck that we often see in pictures. And that can be corrected through having the correct amount of iodine from your diet. And so again, we're looking at the thyroid as it produces thyroxin. Negative feedback is what it's actually maintaining, having the correct amount of thyroxin. We don't want hyperthyroidism and we don't want hypothyroidism. And so how does this work? Well, we're going back up into our brain, and the hypothalamus will talk to the pituitary. The pituitary will then release the thyroid stimulating hormone, which then tells the thyroid, hey, let's make our thyroxin. What happens is if there's no iodine in your body, you don't make enough T4 or T3. If you're not making enough thyroxin, what happens is you can't go back and inhibit the hypothalamus or the anterior pituitary, which then keep telling your thyroid, make more, make more, make more. And what happens as a result of that continuous stimulation is that your thyroid grows and you get a goiter. Now, what happens if you have enough iodine in your diet? Well, then you're going to produce enough T4 and T3. It will go back and inhibit the hypothalamus and the anterior pituitary, which will then stop sending a signal to the thyroid to make more thyroxin, and then you have maintained homeostasis and thyroxin levels. Now, some of the hormones that come from the thyroid or the parathyroid are actually what maintain calcium. So it turns out the amount of calcium in your blood is controlled by two hormones that act against each other. One is calcitonin, and that's being made in the thyroid, and the other one is the parathyroid hormone, which are coming from the parathyroid glands. And so what happens is that we're actually maintaining the calcium levels near a perfect amount in our blood, because if we don't, we can have these like horrible side effects. So here's an example. When we have a rise of the amount of calcium in our blood, the thyroid is going to release the hormone calcitonin. Calcitonin goes out and it tells our bones, hey, start storing the calcium. It tells our kidney, hey, stop taking up too much calcium. We need to get rid of it. And the amount of calcium in our blood falls down. We reach normal levels. However, if we fall down too far and we don't have enough calcium, what happens is that the parathyroid hormones release their parathyroid hormone, which then causes our digestive system to absorb more calcium, so we're putting more into our bloodstream. It causes our kidneys to take up more calcium and put it back into our bloodstream, and it tells our bones, hey, stop keeping calcium, instead release the calcium into our blood, and then the blood calcium levels rise back up to homeostasis. One of the other endocrine glands is the pancreatic or the pancreas. Its job is to control how much sugar is in our blood. So now we're looking at sugar and not calcium. The pancreas, what it does is it controls the amount of glucose we have in our blood, which is sugar, by using two hormones. So if we need to get rid of and to store glucose from the blood, so we want to take the glucose from the blood and put it into our cells, we're going to release the hormone insulin, because that's what insulin does. Insulin tells your cells, hey, take glucose from the blood and put it inside of your cells. Whereas the hormone glucagon comes, and when glucagon circulates, it tells our body to break down the glucose and release it into the blood so it can circulate. So here again is a diagram of how we're maintaining homeostasis. We're looking at what happens if we have too much glucose in our blood. Well, all of a sudden our pancreas is going to be releasing insulin. Insulin then tells our body cells to take in glucose. It tells our liver to start taking up glucose and store it as glycogen. So we're storing the glucose. We're getting rid of it in our blood. It falls back down. If we don't have enough glucose in our blood, maybe after we've missed a meal or we're really hungry, that's that low blood sugar you feel, then the pancreas is going to release glucagon hormone. Glucagon tells our liver, hey, stop storing, break off the glucose that we have from our glycogen, release it into the blood, and then our body can use it and our blood level raises. Now, diabetes is an endocrine disorder that comes from when your cells are unable to get glucose from the blood. As a result of too much insulin, or your body is just immune to reacting to it, what happens is that your cells will start to burn fat or protein versus glucose as its main fuel source. So then glucose remains in the blood, you're peeing it out and you're excreting it in your urine because it's at really high levels, and it can actually be a life-threatening disease. There's two different types of diabetes. One is insulin dependent, which is type 1. This is the one that you normally develop in childhood. It's something that you get through a genetic disorder. It's where your pancreas literally does not produce enough insulin. How do you fix this? You simply get insulin injection shots. That controls the amount of insulin in your blood, which then controls the amount of glucose in your blood. The newest type that happens as a result of our obesity epidemic is type 2, which happens usually when your cells no longer are responding to insulin in your blood, or you simply don't produce enough insulin in your blood anymore. And this often can be fixed by simply going on a diet and eating healthy. Now, the other things that we have for the endocrine system are our adrenal glands. The adrenal glands are these little glands that sit directly on top of your kidneys, and they're actually, you can identify them on the top of your kidneys. And what they do is they talk to the hypothalamus, and often the adrenal glands are responding to things like stress. They're what make our fight or flight hormone, so the epinephrine, the norepinephrine. So what they're doing is they're actually telling our blood sugar, our glucose, where to go so that we can use it to generate energy, because we're getting ready to run. We're getting ready to use our muscles. And because of that, we're going to increase the blood pressure. We're going to increase our breathing rate. We're going to increase metabolic rate, specifically of cell respiration. And because of that, your body is physically responding due to the hormones of epinephrine. Another thing that's going to happen is an endocrine gland is the adrenal cortex. Now, the adrenal cortex is actually the longer problem with stress. What happens is the adrenal cortex hormones get their signals from the pituitary glands in the brain, and they secrete something called a corticosteroid. And what corticosteroids do is they control how much water and salt we have, and kind of control how much minerals are floating around in our body. So here is what is going on in our adrenal glands. They're controlling our response to stress, either short-term or long-term. If you're stressed out on the short-term thing, you're going to start breaking down glycogen into glucose, so you have blood sugar. You're going to increase your blood pressure. You're going to increase your breathing rate. You're going to get ready to fight or flight. But if you're constantly stressed out, like long term, what's going to happen is that your body is going to start to hold on to things like salt and water. It's actually going to increase the amount of blood that you have within your own body. And because it has to pump more blood, your blood pressure is going to increase, which is not a healthy thing to have happen. The other thing that's going to happen is your body's not just going to rely on glycogen to produce glucose for cell respiration. Now it's going to start breaking down proteins and fats. And all of that's going to cause an increase in the amount of glucose circulating in your blood. And that's not good. And it can actually affect your immune system. So you're more likely to get sick when you're stressed out long term. And that's all because of your adrenal cortex glands that are found on top of your kidneys that are controlled by your brain. One of the things about these glucocorticoids that are being produced by the adrenal glands is that they actually can cause relief from pain. And so when you actually have an injury or you take something like an Advil or something, what it is it's a glucocorticoid, or some of you might have had injections for corticosteroids, and it just alleviates all of these problems. People are using them. One of the things is that it actually does lower your immunity. It puts you at a higher risk for diabetes because of that increased glucose levels in your blood. It can actually cause bone fractures because your bones are no longer storing calcium like they should. And so some of the ideas is that it's not always good. We don't want to just add extra things into our body. Our body is naturally producing those things. And then, of course, our last endocrine gland is the gonads, which are your sex things. This is where the estrogen, progesterone, and androgens are found. Both male and females produce all of these different hormones, but they do it in different levels. So testosterone is high in males, low in females. Estrogen, high in females, low in males. They still do produce it. The thing about females is that they have a high ratio of estrogens to androgens. The androgens are testosterone. And that's actually what allows females to produce female characteristics like enlarged breast, uterine, egg production, ovulation, things like that. Males, on the other hand, have high levels of androgens, which are testosterone, and that gives them their male characteristics: deeper voice, chest hair, facial hair, testes, and things like that. And so these are two males, they're fighting for reproductive rights. It's just an example of testosterone in effect. Here are all of the major glands and what they do. You're really going to have to just start memorizing them and looking at what they do and where they're found. The list goes on, but table 26.3 is very important to this chapter.